Hello and welcome to another Solana tutorial. Today we're gonna have a look at runtime specifics. Cause as a dev, I really wanna understand how the runtime handles my accounts such that I don't get weird behavior. I don't wanna have wrong assumptions of what happens. So I want to really understand what's happening to my accounts. And in particular, today I want to have a look at what happens when we close accounts. Specifically, when accounts are closed. And then also, I might want to look at when the size is really changed on an account. Because last time when we had a look at program deployments, we saw that the account was basically closed and then data was read. So I just want to have a better understanding of how that all works and when that all changes. Does it change between instructions or does it change between transactions? And is it different for data than it is for lamperts? Here's the background knowledge that you need to have. Every Solana account needs to have some lamperts, aka sol, on the account such that it stays alive. And how much lamperts that needs to be depends on the size of the account. The bigger the account, the more lamperts. That's the whole concept of rent. We talked about this and I'm pretty sure you know about this. What you probably also know is when you remove all the lamperts from an account, that account gets closed. AKA, if an account has 0 lamperts, it will be deleted from storage. The entire state of that account will get deleted. So in order to close an account, all you gotta do is set the lamperts to 0. And then the runtime takes care that that stuff gets deleted. You probably also knew that, and in case you didn't, that's why I said it again now. But now my question is, when does that happen? When is the runtime killing the account? Between instructions or after a transaction? I'm pretty sure it's done after a transaction. The only other thing that I could still imagine being the case is that it happens after a block. But that seems somewhat unrealistic for me. But it could be. That's gonna be difficult to test. But I'm pretty sure that it's between transactions. My guess would be that it's between transactions. Why is that relevant though? Well, because we need to know that behavior in order to understand how we need to properly close our accounts. If we think it's done after an instruction, but then it's really in that transaction, the user can put something else in the same transaction, then that might lead to problems. That's the one thing. The other thing is, maybe if we want to keep accounts alive, how can we do that? Such that we don't need to recreate and reassign it again. So I just want to play around with this a bit and, share my findings such that we all learn about Solana and how that account closing works. That's my goal for today. Experimentation. Let's start on CLI. Get myself a key pair. Experimenter. Got myself a key. And with SBL token, I can create a token. Apes is my token. Great. And then I can create a token account for this. DLI is now the token account. And if we look at that, this account will be owned by the token program and it has balance for rent exemption. Now, if we close that account, then all that's happening is the token program removes the lamperts in this close instruction. And what this close account instruction does is basically just remove the lamperts. I mean, it checks that there are no tokens on this account, but then it removes the lamperts, puts it back on my account, and then this account doesn't exist anymore. It doesn't exist, it has 0 bytes, and it's still owned by the system program while it's owned by no one because it doesn't exist. But if you create that account again, if you had the private key for it, for instance, then you could, make it a system program account or whatever account again. In this case, we don't have the private key because it's an associated token account. So that's a PDA from the associated token program. Right. So far, nothing new. But what would happen, you think, if in this transaction where we close the account, right afterwards, we fund that account again? Oh, and I'm gonna give you 4 choices. Like, who's gonna be millionaire? Is it A, gonna be the exact same as we had here, and in the end, the token account will just have 0 balance and does not exist? Or B, is it gonna be not zero balance, but have the balance that I transfer there, but it is a system program account. So it will be owned by the system program as if I did, let's try that, Solana transfer to this account, 0, whatever. Oh, hate the CLI. Would it look something like this then? Where it has funds, but it's owned by the system program, not the token program. Or is it gonna be C? It is still owned by the token program and still have bytes allocated for it. Or D, will it be owned by the token program and not have bytes allocated for it? I think that difference, that really depends on the implementation of the token program, I guess. Or E, because I give you a fifth one, will it just not work? Will I not be able to transfer in the same transaction to that account? No, okay, it's not an E, fine. Choose between the first four. I will be able to transfer because I can transfer to any account always. That's how Solana works. Unless it is a protected account. The only accounts that I can't transfer to are write protected accounts like these. I cannot transfer to the system program or the compute budget program, change the balance of a read-only account. The token program, however, I can transfer to that. Oh no, I cannot do an executable account. Oh, that's new. I did not know that. Cool, learn something. Oh, wait, but that's because that... Hold on. So I can also not transfer to the other one because it's an executable account. Yeah. I could transfer to the executable data account though. Yeah, that would work. Look. Now it has a little more, the 2 here. But yeah, anyway, okay. A, maybe E is still a valid option. Maybe I cannot transfer, but I'm pretty sure I can. So, in order to figure out which one is the right answer, well, we just gotta do it. We just gotta build a transaction where we close an account, but then also transfer to it. So step 1, get rid of the CLI and build our own script. Let's see if we can recreate that account. It is already funded, but that doesn't stop us because it just means we need to put fewer lamperts on there because a little bit was already on there. CLI is smart because it was funded by the system program. It just had already some lamperts there. Wait, the associated token program I think is smart because here when it does the transfer, then it just transfers that little. Oops, you don't see here. Right, so we created that account again. Now let's close it. Well, first we need to find out what the account is. And at some point, I will remember, wait, this one was find, right? This one is called find. This is so confusing, but whatever. The mint, oh yeah, hold on. Owner is my payer. That should give us the ATA. Then instructions, close. We close the ATA, back to the payer. Payer is also the owner. This way we would close it normally. But what if we then transfer some SOL? We transfer enough that the account could live on with full rent. So let's say 0.03. Yes, I know how many decimals we need. The destination is the ATA and from my payer. Yeah, why don't we like that? Number is not a big int. Well, make it a big int. There you go. Cool. And then we just send that transaction. Well, first we simulate it and then we send it. Okay, cool. So what do you think will happen to the account if we refund it? A, B, C, or D, or E? It doesn't work. It will work. I'll show you how it works. What did I call it? Close. Close and fund. Boom. There we go. It does work. I do get a transaction. But what happens to the ATA? What happened to the account now? What do you think? Is it owned by the token program? Is it owned by the system program? Is it closed? My guess, I would say I think it was C. My guess is that it's still owned by the token program. Because even though this instruction removes all of the lamperts, if we put on lamperts in the same transaction, I think the account is never really deleted. That would be my guess, but let's have a look at this transaction where basically we see it's just refunded. It's even funded more to 0.003. So first the close takes it off, but then we put more on again. But who is the owner of this account? Drum roll, please. Oh, it is the system program. I got that wrong then. I would have expected that the token program still owns this. Cool, so that means that's a regular system program. It has 0 bytes, so at some point it was deleted. Okay, let's try something else. Let's not work with a token program, but create ourselves a nonce account. Get create account instruction. I need less than that, but I can't be bothered to get the exact numbers, so that's what we do. Actually, can't have the same name. I can't have that name either. I hate the new Web3.js. New account. And it's not a program derived address. This one is a get, what was it? If I want to create it with seeds, is there a separate one for get create account with seeds? Oh yeah, that's a separate instruction builder. That's interesting. Okay, I want to have this one. You don't need lamperts? That's interesting. Okay, so let's just go with this. Just to get practice in the create account with seed. The base is the pair. Wait, what is the base account then? Oh, amount. Wait, is amount the lamperts then? Amount number. Oh, this is odd. For the get create account, you call it lamperts, and here you call it amount. That's just weird. And then you don't even want lamperts. That's just weird. Seed. My seed. I don't know. Just seed. I don't care. Base account. What's the base account and what's the new account and what's the base? Why do we have 3 things here? This is confusing. Just to get the types right, let's say payer. A new account would also be payer, which of course it is not. But base account, oh, that's the guy who needs to sign. Yeah. And the base, that's just the address. I mean, maybe it can't get the address out of the signer, the base account, but then why is the base account the signer and the base the address? Am I doing something wrong here? Probably, but it doesn't matter. Anyway, it's also very confusing the way I do it. Basically, we do a create account with those lamperts that they call amount. This space, we assign it to this program. We are paying, that's the payer. And then base is also my payer and the base account. And that stuff is used to derive the new account. So it's basically kind of a PDA of the system program, except not really. Watch the with seeds video to get the explanation for that. And the new account, this guy, we kind of need to derive it with this base and seed, but I don't know what the function name is. There must be something in here. Maybe the docs of this thing tell me something. Nope. Create account with seeds, data args. And the new account is an address of type new account. Well, that's just not helpful. In the old Web3.js, it was in pubkey and it was like, where did the new Web3.js hide it? Get program derived address. Maybe where that is, we also find the other thing. Yes, create address with seed. This is a create address. The naming of the new Web3.js is so confusing. You need this, a create. Okay, we create. Why is that a get and not a find? And why is that a create and not a get? It does the same anyway. It derives an address. Why can't we call it derive? Anyway, sorry, I just get a bit annoyed if I need forever to find. But hey, I found it. Create address with seed. You just gotta know it. You just gotta know, and then it's easy, right? So what you need? Base address, easy, my payer. Program address, easy, system program. Seed, easy. There, have the seed. Okay, and if you're confused why I just delete that, then it takes this. Watch my TypeScript tutorial. What else do we need? So we have the new account that goes in here, and it's not happy with this because that's a promise. And now it's fine. Okay, wonderful. Why is that yellow? We don't know. But yeah, like that we can create an account with seeds. Perfect. And then in the same instruction, we get an initialize nonce account. So basically we make the new account a nonce account, payer shall be my authority, boom. And like that we create a nonce account. Let's just do that. Create nonce account. Will it work? Yep, gives me success. So here we created this account, the 4C right, created with a seed, allocated 80 bytes, put enough rent, initialized it as a nonce account, such that this guy is now a nonce account. Cool. And now we do the same thing with that nonce account that we did with the ATA, and that we close and fund nonce account. We get a withdraw nonce account instruction. This is what I would use to kill the nonce account. So my nonce account, my nonce authority, recipient is the payer. Withdraw amount is the fund amount, because that's the same. So here I withdraw everything and then I transfer again. Without the transfer, let's just do without the transfer to showcase that this would kill the account. We now have the account, it's a nonce account, and if we just close it and refresh here, then it will be an empty account again. There we go, this account does not exist, it got deleted, 0 bytes, still owned by the system program, or really no program really. So that works. Let's recreate it such that it is a nonce account again. And we can create the same account because we have the same seeds and the same base account. Different block hash in there now, but who cares? So what happens if I do the same thing, but this time I transfer to it? Will it A, do the exact same thing that we also saw with the token program and have an empty account that is owned by the system program? Spoiler alert, it will definitely be owned by the system program because a nonce account is also already owned by the system program. So I'm pretty certain that it's gonna be owned by the system program. Even an account that is deleted is owned by the system program. So, you know, it will be owned by the system program. But will it A, be a regular account with 0 space? Because for now, if we don't see that here because it says nonce account, but if we check it here, it actually has 80 bytes in length and has data in that account, and it is owned by the system program. Will it have 0 bytes and be owned by the system program? Or will it B, have 80 bytes and be owned by the system program, but the bytes are all 0? Or C, will it have 80 bytes and the bytes are still all the same like here? Or D, will it have 0 bytes? Wait, was that A? No, that was A, right? I already forgot what my options were. I need to remember what I said. This is difficult. What would I expect to happen? Or D, something completely different that I don't expect. What would I expect though? I mean, I'm transferring out in this instruction. So after this instruction, the account has 0 lamperts. But I think the withdraw nonce account doesn't do any like cleanup. So really what I'm expecting is that I can save the nonce account. Although if the token account that we closed earlier was any indication, then we would expect that it's a completely empty account with 0 bytes and 0.03 sol. So those are my two. Can I have a 50-50 joker? I go with the I'll gamble and I go it's still a nonce account. I go with it's still a nonce account. What's your guess? Let me know in the comments, or don't. Maybe I disabled comments, who knows. Make the guess for you. What do you think? Will it still have bytes or will it not if we do this? There's only one way to find out. Let's actually do this. We get success with the 2 system program instructions. We sent it. Before refreshing this, I'll check out that transaction. Well, we don't really get the hint yet. I mean, we paid for transaction fee and that account still has 0.003 sol because after the withdrawal, we transferred the same amount to that account again. But the question is now, is that still a nonce account or is that now an empty account? Let's go check. It is not a nonce account, but it still has 80 bytes. Okay, that's interesting. So it was option B or whatever, the one that I didn't take. It did keep the bytes, which makes me think that the close token account instruction actively sets the account size to 0 as well, which the withdraw nonce doesn't do. So if we check that account again, that's interesting though. It's still owned by the system program and it still has the almost exact same data, no? Has the exact same data, right? Didn't overwrite the data. The data is still there. Oh, here. There we have a 0. It did change something in the account. This one, some flag, hold on. So basically just invalidated the account, I guess. Should we look at that? Just because I'm interested in. So we have uninitialized, initialized with data. And I guess data is the authority. So what's the first byte and what's the first 4 and what's the second 4? Since that is already the pub key, I guess, I would think that this is the state. So that means it's still initialized here. And here it's not initialized. And then this is something else the system program does to it before that. Yeah, here we set to uninitialized. If we remove all lamperts, we set to uninitialized. Otherwise, we check if we still have minimum rent. Yeah, so we do set it to uninitialized if we remove all the lamperts, which is what we did. So it's not a nonce account anymore, but it still has all the data. So we saved the data if, and that's the important thing. So if your program would not do that and set a state to uninitialized and would just leave it, then basically I could recover the entire nonce account or the entire data account by just refunding it. So just setting the lamperts to 0 is not enough from a security perspective to guarantee that your account gets closed. That's why here they set it to uninitialized. But we still have the data, which also means that from this account I couldn't transfer out the sol anymore. I would still need to withdraw nonce account, this instruction instead of a transfer. If it's uninitialized, we check who needs to sign to do this. That's fun. Wait, that's interesting though. So as a challenge, let's say you have such an account and I don't know, for some reason, there's a lot of sol on there. Let's transfer, because we can, I don't know, an entire sol there. And we pretend we're on mainnet. And that's, quite some money if we were on mainnet. How can I get this off now? What's the strategy to receive this? What's your guess? Do I need to make it a nonce account again, like initialize a nonce such that I can then withdraw? Can I just withdraw with a transfer? A normal system program transfer? Can I withdraw from nonce account even though it's not an initialized nonce account? Could I withdraw though from nonce account directly if I had the signer for this? Like if I had the private key for this account. If that wasn't created with seeds, but with a regular private key. What's your guess? My guess is A would be possible, but is it the only option? I think D is also an option. If I could sign for this one, then I could withdraw, not with a transfer, but with a withdraw from nonce account. And otherwise, I think I can't. But let's try. See, we're going from one thing to the next. This is just how I like to learn, because that's a challenge, that's a puzzle. How can I get that sol off? Because basically that's what I do when I try to recover funds for people. Somehow they got funds stuck in some protocol, and now my challenge is, how do I get it out? With the given constraints that their account is bricked, their ATA is claimed, something like that. It's just, and here our constraints are, there's still data on this account. It is owned by the system program. How can we get it off? And that's a good challenge. I like that sort of challenge. So I recommend that you try it out yourself as well. Or, you just watch me do it. But if you do it yourself, I think you learn more. So let's try the first thing, which I think will not work. Let's do a get transfer sol with seed instruction. Destination, I put it to my payer. I want to get it back. From seed is my seed, and from owner, what's that again? I think just, it's so confusing, guys, that you have so different names. That's what the other thing called the base, I think. Let's see. I don't think that will actually work. I think it will tell me, hey, there is data on this account, I can't transfer. That's what the system program usually says in those cases. Yep, we get a custom program error 0x5, which states that this address does not match derived address. Oh no, that's completely different. Maybe there is something different. So destination, that's the receiver. That should be fine. base account, that's the signer. That should also be fine. From seed should also be fine. From, oh, the owner, of course, the owner is the program is the owner, not the, yeah, that's not the base, that's the program. That's so confusing. What did you call it here? Here you called it the program address. Guys, man. Having 3 different names for the same thing is just... I should have looked at that before they released the new Web3.js, but now it's too late to make changes. Great, that's what you get, Andy. Your own fault, I know. Okay, but this time it should have the correct address, and it will still fail. Invalid program argument, yeah, that's what I expect. The from, so this guy, the from account, the source account, this guy, that's the from, which here it calls source. Thank you. Must not carry data. And it does have data. It has 80 bytes of data. So a normal transfer doesn't work. Even if we had the private key, it would be the same. We couldn't transfer. So that doesn't work. But what if I withdraw? Can I withdraw with seed? There is no withdraw with seeds. And this will most likely also fail because I'm not signing for this account, I think is why this will fail. Yep. Missing required signature for instruction. Withdraw nonce account. This guy must sign. I can only withdraw from here if this guy would sign. And since I can't sign with this because I was never able to sign with this, I created it with seeds from a base key. So I can never sign with this. So my only option is to actually make it a valid nonce account again and then withdraw. Can I even make it a nonce account still? I mean, I guess so, but let's try. So basically, I do the create nonce account, except I don't create the account because it already exists. Initialize nonce account. Do you think that will work? Yeah, that would work. And then in the same transaction. So I initialize it as a nonce account and then I withdraw. Because then when I withdraw, I need to sign with the authority and the authority can sign. So that's the way how I can withdraw from this. No, I cannot. Nonce can only advance once per slot. Aha, and if I initialize the nonce account in the same transaction as I withdraw from, then that doesn't work either. Because the withdrawal will also advance the nonce account, or withdrawing everything would. Wait, what if I only withdrew not everything but just one sol? Would it then also advance? No, then that would work. Because then it wouldn't advance the nonce account because the nonce account would live on, but I could withdraw everything. Look at that. I'm gonna send this. There we go. As long as I don't withdraw everything, because if I withdraw everything, then it changes the account. We saw that in the source as well. And like this, I could withdraw the one sol. I just needed to make it a nonce account first and keep some sol on there for the nonce account to stay alive. That's funny. So we played around with nonces a bit, or with nonce accounts, really. And like this, the account doesn't get deleted, of course. That's nice, that's nice. So to answer though, in this case, it would be A, I need to reinitialize the nonce account. However, just to also prove that real quick, if I could sign for that, then it would be possible. If I had a key for my nonce account, there we go. So my new account would be this, not derived. And then I don't do the base and seed stuff. And I don't do with seeds, but just create account. Then I need to call this Lamperts. Ugh. And the new account address will become a nonce account. And if I then create nonce account from key, there we go, Noi. Then we have this new account NCE, which is the nonce account. And then if we do the weird thing with the close and fund nonce account, but instead of this, I'm just gonna hard code it now. We do it for that account. And then let's put accidentally the one sol already there. There you go. Now we accidentally closed and refunded this one. So now it's not a nonce account anymore. It still has those 80 bytes, but it's uninitialized. And like this, here I should be able to withdraw. If I now withdraw from this nonce account that I can sign for, wait, this will still not work because we're still signing with the payer. Let's show how this won't work. There we go. Then we once again see this account itself would need to sign. And if I would put the nonce account itself as the signer here, then I guess I can withdraw. Yeah, look at that. See, here option D is valid. If I can sign with that account, then I can directly withdraw everything. There you go. I withdrew everything from the nonce account. Just with the system program withdraw from nonce, because I was able to sign with this one. Cool, good. That was an excursion to nonce accounts and how to withdraw from those. Let's bring it back to, that's a lot of files. And they're all red. Why? Oh, because of that? Great. That's what you get because the Web3 is having weird names. And that's what you get for always copying your entire file. Ha, looks better. Okay, good. So what did we learn? That putting it to 0 lamperts does not actually delete the account in the same transaction. I could fully recover it if I put more lamperts on there again. That's why when you close an account in your program, you also need to somehow change the state, which is what the token program does. I think the token program even allocates it or sets the data size to 0. So here it would be very interesting then if I could allocate more data again. I'm gonna play around with it a little more, and I think I need my own program to have more control. Let's go with Solana program. For once, I'm not gonna use Pinocchio because I am going on DevNet anyway, so I can afford it. Our simple program. What should I do? I'm gonna ignore all the checks. I'm just gonna quickly make something work. I'll have 2 instructions, 1 and 2. We'll do an initialize instruction and a close instruction. Just takes 1 account. And at first, our initialize does nothing, and the close, all that does is put 2 accounts. The first is the one to close, the second is the receiver. So yeah, and that way I consider my account closed now. Let's see if that would actually work. I need to deref it twice. Ah, there we go. Why do I have 2 times deref? What do I get here from the unwrap? Ah, I have a result that I unwrapped, and I have a reference to a mutable reference. There we go. Okay, so that's why I need to unwrap twice. There we go. And then this equals 0 should also work. There, that's what we do. Okay, let's do this. And instead of a checked add, we do an unchecked add. There we go. Safe. We won't get an overflow in lamperts. This is highly unlikely. And otherwise the runtime will kill us. It's fine. So this way, that should work. Build. Ah, we've been here. I have a whole video on how to fix this with installing a new Agave version, right? You know what? Can you please just use 2025? There we go. Better. Okay. Build, deploy, experimentation program. Nice. And my experimental program is deployed. Cool. Let's call it. Program ID, address of this, call our program close. We need an account to close, so new account address, writable, and the receiver shall be the payer. Okay, that's the thing for close, but before we can close the account, we need to create it. Borrow this, and we fund it with, I don't know, 0.005 sol, make it 100 bytes, who cares? And assign it to my program ID. Let's see. Should we do that in 2 transactions or in 1? Maybe let's do it in 2 transactions. But then I need to copy the account key. Nah, let's do it in 1. Who cares? That actually works. I can call the close instruction on my program and it gives me success. Nice, first try, not bad. So basically I created this account, allocated some data, and then here I removed everything again. And then afterwards it's an empty account that doesn't exist. So nothing unexpected here. Let's do it in 2 steps just to show. Just create the account first. This created me this account, the 5XS. And then I just call the close with a new account, just close. Account to close this guy. And I don't need to sign for this anymore because this now belongs to my program already anyway. I can just put in that account here and it will be fine. So if I now just close this account that has 100 bytes and is owned by my program, if I close it by just removing the lamperts, remember that's all that my program does, it just removes the lamperts, then boom, it does not exist anymore and it has 0 bytes. Okay, so far so good. Nothing unexpected here. But what if we call a refund? I do this, I create the account, I close the account, and then immediately after I fund it with some sol again. What do you think will happen here? After my close, I refund it. Will it A, be owned by the system program? Or B, be owned by my program still and still have data? And my answer is B, it will still be owned by my program. So let's try the refund. We create the account, we close it, and then we transfer again. So in the end, it will still have 0.005 sol, and it will be owned by my program. Yes, my program. And it still has 100 bytes. What would happen if my program would now try to assign the account to the system program? To make sure that it's not my account anymore, I'm gonna try to assign it to the system program. Let's see how I can do, if I can do that. So in my program, not only do I transfer the lamperts, but the account to close owner, that's a pub key, I cannot write to this. Can a program change the owner of an account? I can only borrow the data or the lamperts. Well, I guess I can assign. Nice. And the new owner, what does that need to be? Bytes or what? Pub key. Well, have a reference of pub key. Default, because that's the system program. It's all zeros. Or all ones in base 58. If I do that, what do you think's gonna happen? Like, do we expect? Like, let's build this, redeploy this. What do you think will happen now? I'm not gonna give you I'm gonna give you the same thing as before. It's still gonna be owned by my program and this assign just doesn't do anything. Or it will just be assigned to the system program and the system program will have that account with 100 bytes now. Or, and this is what I believe will happen, the runtime is gonna kill me and not be able to successfully do that transaction because I can't assign an account that has data. I think. That's my guess. What do you think? Completely unbiased, of course, of what I said, because I've been wrong before in this video several times. So make your own guess. Maybe there's a fourth option of, I don't know, what else could happen? It's automatically set to 0 bytes, maybe. It's a possibility, I don't know. However, I don't think that that's the case. But who knows? It's at 0 lamperts already. Maybe the runtime says, yeah, whatever. Is it the runtime that does the checks here between instructions? So anyway, so my guess, as I said, is if you try to refund this, close and then put funds again, the closing will not work if I assign a new owner of an account that has data. I think it's just gonna kill us. No, it is not gonna kill us. It is not gonna kill us. I was wrong. I just obviously on purpose misled you such that you think about it yourself. No, I was just wrong. Okay, cool. So it worked. We created that account. We closed it with the program. We transferred on there again. So my new guess is the assign just didn't do anything. My guess is this account will still be owned by my program. And no! It is owned by the system program and has 100 bytes. Oh! Yeah. I misremember. I know. Okay. I love this. I love this when I realize what's going on here. Ha! Yeah, it's not that it can't have bytes. It just can't have bytes with stuff written in the account. But since there's no data in the account, like we have allocated data, but it's all zeros. That's also what happens if the system program allocates. That's fine. System program can allocate data as long as it doesn't write any data. It can still then assign to some other program. And that's true for all programs then. Yeah. Okay, yeah. Yeah. Okay. Fun. The next funny thing is, how do we get this off of that account now, even if we had the private key, which we had at some point, because we can't transfer if there are bytes there, right? That was our problem before. Or can we transfer because the bytes are all 0? I don't know. We should totally try that out. But first, don't let me forget to try that out. But first, let's do a proper initialize. This only works because we don't have data. If we were to also call our initialize, and the initialize would actually do something like account try borrow data mutably, please. Just gonna set the first referenced. Okay. Easy. We just set the first byte to 1 to say it's initialized or whatever. What if we were to do this? Build this, deploy this, and then rerun this. My guess is I will fail now. Yeah. Instruction illegally modified the program ID of an account. It's illegal because it has data. If it has data, we're not allowed to assign it to someone else. If it has data that is not all zeros. Yep. Cool. That's also a runtime thing. You need to know that. And we see that here. Actually, let's dig deeper. I'm gonna dig deeper. We're gonna do a third one. Assign, process assign, and we're gonna split this part from the close and do it here, and close this first, assign this first account here. This one, assign to the system program. Do it in 3 steps. If we don't assign, by the way, so let me quickly rebuild and redeploy this. And if we don't assign now, just initialize and close, that should be fine, right? That should work, because then we're back to what we did before, where we just, create that account, and then it has still 100 bytes and is still my account. That's fine. We're not assigning it to the system program. And there's actual data on there now. That account has 1 byte of actually written data. But what if my refund would now also do the reassign? It's basically the same, just with instruction 3. We get the same thing. We initialize, we close, we assign, as if that would have happened in the same instruction. So we see that between instructions, the account is not cleared. The account here, even though here in this instruction I put it to 0 sol, in this instruction, it still has the data, it is not being cleared. And that answers my initial question, when is the account cleared by the runtime? It's after that transaction. So if I wouldn't do the assign, and then I transfer to the account, and then I transfer the same amount back to my payer, this will not work because this account is still owned by my program. See, also it still holds data. Not only is it not owned by the system program, it also holds data. And that's the thing that it checks even before it checks the ownership of the account. And that's why we get that error here. However, if I were to do that in 2 separate transactions, like if there was a transaction boundary here, so those 2 we do in a separate transaction. And let's see if that changes something. The first one goes through and the second one right after. So at the first one, we created this account, but then immediately removed funds from it again with the close instruction. So that was in block 604 and then in block 605. So we also crossed the block boundary, but more importantly, that transaction boundary, where at the beginning it was already 0, so it didn't have data and it was not assigned to my program anymore because it had 0 lampots, it was cleared. And then I could transfer there and transfer back because it's now owned by the system program. And now it's again empty because I transferred it out again, where it's still owned by the system program, because we had to wait for the transaction to be over. Can we actually prove that it's not the block boundary but the transaction boundary? Can we be like, maybe we skip pre-flight? Maybe that's gonna be enough already. Nope. Okay, gotta be faster. We will not await this and then send right away. What could happen is that we fail. The problem is it could also have happened then before How do we ensure that it's not happening before? Well, let's just try it. So they are sent in the same block now at the 196. But how can we guarantee that it's which one was before? Let's check the block. It's not that many transactions. I should find mine. So this one was the one with the system program that was at spot 9. And this one, that's 11. Okay, so this one is actually then afterwards. I was afraid that this would happen, that the one with the we send and we remove would happen actually before. So we didn't prove anything. We need to switch it. Maybe it's even enough if this one compute budget. Yeah, we will just add an instruction because we're on DevNet and I'm rich. Ridiculously high priority fee because it doesn't matter. I'm on DevNet, I can afford it. Maybe if they're sent at the same time, this way it will prioritize this instruction. Let's try. And otherwise I need to find another way to make it wait a bit. Let's see where they sent in the same block. 748, 748. So let's check the 748. 46 in this one. Let's see, where is mine? So the second one was actually at space 9, but the first one at 4. Ha! So it is in the same block with the... Wow! Did I pay 0.6 sol in priority fee for this? Worth it! Worth it! Totally worth it. So here in this transaction, I, created this account and then initialized it and then closed it again. So at that point, it was still owned by my program, but then it had 0 lamperts. So at this point, right after this transaction here, from here to here, that account got killed, deleted, and set to 0, like it doesn't exist, so everything was 0. So when this other transaction, this one, came along and just funded it with a transfer, it belonged to the system program and not to my program anymore. Cool. So we figured out it is the transaction boundary, not the block boundary, because in the same block, it also happens that it's cleared out. It just needs to be 2 different transactions. Nice. Very nice. Yeah. And I think that answers my question. I think I'm good. Like this is, we learned stuff and it's been a while of me recording here anyway. I don't want to make this video longer and look at, more, even though there is more to explore here. But one last thing I still want to do, because I promised you that I will do this. For an account like this that I initialize, if I initialize it, I can't assign it to the system program. We figured that out. But what if I don't initialize it? It has data and I assign it to the system program, back to the system program. I mean, that's the same as if the system program would say allocate or just, create account and create the account for not my program, but the system program. So I could, make this easier for myself. But let's stay complicated to this refund. So basically we created an account now, the 2Pi, that belongs to the system program. It's owned by the system program, but it has data. Allocated. It's all zeros though. And my question is, can I transfer out from this account? My answer is yes, but only if I have the private key, which for this account I don't have anymore. I threw it away. Well, I created it and then I signed with it and then I didn't remember it. It's just a generate new key pair signer. Don't do this, kids, with actual proper sol that you might actually on mainnet spend. Yeah, we should have remembered this, but let's just do it again then. Well, let's just copy this. So we do the same thing here. We don't initialize, we assign and we transfer again. And then let's see if I can transfer a bit back. So let's see. Call program, assign, then transfer. No, we cannot. It also says we cannot transfer from here because it must not carry data. So even if it's all zeros, I can't transfer out if I have data allocated, even if it's all zeros. Learn something again. Can't do a system program transfer. How could we do that? Well, we need to delete that account. So the challenge, we now have a challenge again for an account like this that we created here, that is owned by the system program but has 100 bytes. How can we get that off? And I leave that as an exercise for you, because I totally know how it's done. I mean, I have ideas. One way how you can do it, of course, is to create a nonce account and then withdraw from the nonce account. I mean, it's a funded account that you can even sign for. I think you don't even need to be able to sign for this. Do you? I don't think so, because you only need to sign for it when you create the account. Then the system program is like, well, you gotta sign for this. You gotta sign for the allocating data. You don't need to sign for transferring there, but for allocating, which is basically the same as creating, but for the system program, because the create is basically transfer and allocate and assign, all those three together. And for the transfer, we don't need to sign, but for the allocate, do we need to sign for the allocate? I think so. But I think then I could make this a nonce account without even owning that account anymore. If somebody created this, it's owned by the system program and it has data and it is funded. Do you think I could just steal that? Create account instruction. Let's say that already happened. And for the initialize nonce, I don't think we actually need to sign with anyone. We just say, hey, take this account and make me the authority for it. There. So I mean, let's see. I think that will do. Nonce account from funded account. Yeah. Look, I can do that. I can just claim it. I can be like, hey, yeah, there was an account lying around. I mean, I created it earlier. But yeah, now it's definitely mine. Now I have the authority over it. And it's a nonce account. And I can withdraw from it as you would regularly. That's pretty fun. So people, don't leave accounts lying around with allocated data that belongs to the system program. Don't do it because attackers can steal it. I learned something new today. Well, great. I teach the hackers again. I don't get around not teaching the hackers. It's stupid. But yeah, I mean, how often does that happen? Are there accounts out there that are owned by the system program that have data allocated, but they're all zero? I don't know. I don't think so. But yeah, that would be one way. Because with a normal transfer, it doesn't work. Can I allocate 0 bytes on it though? Could I be like, hey, this is my account. Can you allocate 0 bytes on it again? To allocate, I need to sign. Okay. So instead of doing a transfer, we get allocate instruction. I allocate it back to 0. Assign then allocate. First one goes through. Second one, account address already in use. I cannot allocate because that account already exists essentially. Because the allocate is basically like a create then in that sense. So I can't allocate it back to viewer. That would need a different thing. Can I ever reduce the space? Yes, by writing the data length a different value, then I reduce the space. But that I leave as the topic for another video, which could be super interesting actually. Looking into how to reallocate data accounts, when that actually takes effect after an instruction or after a transaction. It's fun, but I will leave it for today. It's been a long video and we learned stuff and that's cool. I've wrote a bunch of scripts. Oh man, yeah, it was fun. And also a short little program. Yeah. Okay, we end here. Thank you for watching. We answered the question that we had in the beginning of when is the account actually deleted, and that's after the transaction. Within a transaction, between instructions, it still lives on. So you still need to be careful when you really want to close an account that you write on the account each state should be uninitialized, or you write some closed anchor that writes the first 8 bytes all once to mark it as this one has been closed, just overwriting the account discriminator, just to make sure that if some attacker or evil person or unaware user does something else in the same transaction with your account, that your program logic still doesn't treat the closed account as a regular account. You can of course make sure that there are no other instructions in the transaction with the instructions syswa, but that's complicated and limits the use cases of your program, doesn't make it particularly composable. So therefore, just make sure that when you actually close an account and you remove all lamperts, also write something to the data or zero out the data just to make sure that it's not messed with. Because anybody can create an account and assign it to your program, in case you weren't aware of that. So just because it belongs to your program doesn't mean that, you created it. But you can be sure that the data that is in that account was written by your program, and to also be able to make sure that if you close an account, that state of it being closed persists. You might want to write something onto the account just in case somebody reactivates it. So that's from a security standpoint. For me, it was also interesting to analyze, well, what happens if I close a token account, for instance? Can I then immediately after reuse the same account for something else if it was an account that I signed for? And the answer is yes, but only if the program itself assigns it back to the system program, which the token program does. It sets the data length to 0 and assigns it back to the system program, and bam, we can use it again. Yeah, but there's still so much more to explore. Like, what if there was data on it and we just set the length to 0? Is the data still there? Could that still be read in the same transaction by a different instruction? But it's enough for today. We learned a bunch. It's cool. I like it. You know what else is cool? Some other videos. Giving this one a like and subscribing, and then watching my next ones. Till then, bye-bye. Learning about Solana runtime. Yeah.